Hello friends, welcome to our channel. Today we are going to see the video related to foundation engineering in the topic of settlement. So the settlement of foundation is mainly based on the settlement of soil. So the settlement is the sinking of soil structure due to compression or deformation of underlying soil. So the soil will get settled down due to the structural rearrangement and overburden pressure. So this is called settlement. So the settlement is broadly classified into two types, that is immediate settlement, another one is consolidation settlement. So the immediate settlement means, so after applying the load the soil will settle down immediately due to some immediate actions, then the overburden. So that is called immediate settlement. So the consolidation settlement is, so after applying the load, so it will take some time to structural rearrangement and exclude the water content in the soil, so that will exclude outside. After that the structural rearrangement will be happen due to the vacuum created soil is exploded. Okay, so now the soil will get settled down in the rapidly for the duration of 1 year or 2 years. So that is called consolidation settlement. So the consolidation settlement also broadly classified into two types, that is primary consolidation settlement, then secondary consolidation settlement. So after the immediate settlement, so the soil will take place the structural rearrangement, so that will be settled over the period of 1 year or 6 months. So that is called primary consolidation settlement. So another thing is secondary consolidation settlement. So the water molecules will excluded from the soil. So after that the vacuum will be created. So then the structural rearrangement will be takes place. So the secondary consolidation settlement will be takes place. So now the total settlement is summation of consolidation settlement as well as immediate settlement. So the immediate settlement is mainly based on the uniformly distributed load, then how much loaded area will be takes place, then modulus of elasticity and Poisson ratio of the soil. Okay, so but the consolidation settlement is mainly based on the compression index, then thickness of the compression layer. So then what are all the effective stress and stress increment will be takes place. Okay, so now we can take this is the effective stress. So the effective stress then in the overlap period, so how much incremental in the effective stress also we have to consider. Okay, so this is the formula we can use for secondary consolidation settlement. C into cc, that is compression index, divided by 1 plus e naught, that is initial void ratio. So the initial void ratio is there, so after that the void will be created due to some overburden. Okay, so now the H, the thickness of compression layer, then log sigma naught, that is effective stress, plus sigma the changes in overburden pressure, so then divided by sigma naught. Okay, so this is a formula we can use to find out the consolidation settlement. Okay, so now we're going to see one numerical solved numerical example for how to calculate the consolidation settlement. Okay, so now a soft normally consolidated clay layer 6 meter thick, so the thickness of layer is 6 meter with the natural water content of 30%. So then clay has a saturated unit weight of 17.4 kilonewton per meter cube, then the specific gravity of clay is 2.67, then a liquid limit is 40%. So the liquid limit, the compression index is mainly based on the liquid limit, so the liquid limit is given. Then the water level at the surface, so the soil is fully completely saturated. So now we have to determine the settlement of foundation. Load will be subjected at the center of the clay layer and the vertical stress increment of 8 kilonewton per meter square. So the vertical stress increment also given. Okay, so now first thing is we can write the formula, that is SC equal to C into Cc divided by 1 plus E naught into H into log sigma naught plus del sigma divided by sigma naught. Okay, so here they are giving del sigma equal to 8 kilonewton per meter cube. So that is vertical stress increment is given. So the 8 is given. Then Cc value we have to find out. The H is given. That is thickness of compression layer is 6 meter. So now we have to find out the E naught. So the E naught is initial void ratio. So now W into G. So now the W value is given. So W is water content is given, that is 0.3 into G is 2.67. Okay, so C gravity also given. So now solving this we got the value of 0.801. Okay, so now E naught also we found out. So next thing is Cc. So Cc value, so we know the formula 0.009 into WL minus 10. Okay, so this is the formula we can use to find out the Cc compression index. So now we can substitute 0.009 into liquid limit is given, that is 40% minus 10. So now we got the value of 0.27. Okay, so now the Cc values we found out. Then E naught value also find out. H is given. Then we have to find out this sigma naught value. Okay, so now we can take the effective pressure. So now we can take the layer. So layer thickness is 6 meter. Okay, so it's a completely saturated, so the water level is here. So now we can take the center of the layer, because the load will be subjected at the center of the clay layer to the vertical stress increment. Okay, so now the load is subjected to the center of layer. So now we can take the center of layer, that is here is 3 meter and here is 3 meter. Okay, so now we can calculate the sigma dash value. So now sigma dash, that is sigma naught. So there is effective stress equal to total stress minus pore water pressure. So now we can take the total stress equal to gamma saturation. So because the water limit is in there, gamma saturation, completely saturation into 3 meter. Okay, so why? Because we can take the H value as the 3 meter. Okay, so this is the Z value. Now sigma equal to gamma saturation 17.4 into 3 meter. So now we got the value of 52.2 kilonewton per meter square. So then the water level in the top of the layer. So now we can take gamma mu equal to gamma W into 3 meter. Okay, so now 9.81 into 3 meter. Now we got the value of 29.43 kilonewton per meter square. So now sigma naught equal to sigma minus mu. So sigma is 52.2 minus 29.43. So now we got the value of sigma naught equal to 22.77 kilonewton per meter square. Okay, so now we know all the values in the formula. So now we can directly substitute Se equal to C value is 1 and 2 into Cc value is 0.27 divided by 1 plus E naught value is 0.801 into thickness of the layer is 6 meter into log. So here we cannot take the 3 meter. Here is the thickness of compression layer. Okay, so the load only acting on the center of layer. So now log into sigma naught value is 22.77 plus del sigma is given, that is 8 divided by 22.77. Okay, so now solving this we got the value of Se equal to 0.087 meter. Okay, so now we can convert into mm, that is 87 mm. So this is the consolidation settlement. Okay, so this is a method we can solve the problem. Again, we'll see next video. Thank you.